Welcome students. In this lecture, I shall discuss how to write Python code to evaluate convolution of two functions. Before we going to writing the actual Python code, first we shall discuss briefly about the convolution of two functions. The convolution of two functions fx and gx prime is written as f star gx, which is defined as minus infinity to plus infinity fx prime g x minus x prime dx prime. Here x prime is the dummy variable of integration, and this convolution is the product of the two functions fx prime, and other is the shifted specially reversed function. Sometimes the convolution is also written as 0 to x fx prime g x minus x prime dx prime. The convolution of two functions basically evaluates the area of the overlapping region between the function fx prime and shifted specially reversed function of the function gx. Let us first consider the convolution of two unit step functions. The unit step function is defined as ux is equals to 1 for x greater than 0, otherwise it takes the value 0. Now this is the graph of the ux prime, and it is clear that for x prime is greater than 0 it assumes value 1, otherwise it takes 0 value. Now this is the sketch of u minus x prime. For x less than 0 it assumes 1 values, otherwise it takes 0 values. Now we want to draw the graph for ux minus x prime, where x prime is any arbitrary value. Now we consider two different cases. For case 1, when x less than equals to 0, the graphs will be like this. This saffron colored graph is for ux minus x prime, and the blue colored graph is for ux prime. Now we want to calculate the product of the ux prime and ux minus x prime when x prime is less than equals to 0. Now it is clear that when x prime is less than x, the product of the ux minus x prime and ux prime is 0, because this is 0 value and this graph assumes 1 value, so the product of these two functions between this region is 0. And similarly, product of the function ux prime and ux minus x prime for this region is also 0. So there is no any overlapping region of these two functions. So ux prime into ux minus x prime is 0. So the convolution of these two functions for x less than equals to 0 is 0. Now what happens when x greater than 0? Now for x greater than 0, this saffron color curve is for ux minus x prime, and blue colored graph is for ux prime. Now when x prime is in between 0 and x, it is clear that the two functions have assumed same value plus 1, so the product will be 1. And in the and when x prime is less than 0 and x prime is greater than 0, the product of the two functions is 0. It is clear from the diagram. So ux prime into ux minus x primes have only non-zero value for x prime is in between 0 and x, and in this region the value product is 1. So the convolution of the two functions f star g will be equals to minus infinity u x prime u x minus x prime dx prime. This value is 1, so integration value is x. So if we combine these two cases, so we can see that the convolution of the two unit step function is x for x greater than equals to 0 and 0 for x less than 0. This is the convolved graph for unit step functions. Now I shall write the Python code for the two unit step function. For this purpose, we will open a file, say unit.py. This is the convolution of two unit step functions. To write the Python code, first we will import some modules from the Python. First we import the NumPy module. So import NumPy as np. Now we will import sims function, which is for the integration, and from the scipy.integrate function. So from scipy.integrate import sims, and for plotting function we will import matplotlib.pyplot. So import matplotlib.pyplot as plt. Now we take the range of the x values. So this is range of x values. Say a comma b will be say we take the x range from -5 to +5. Then we shall define the function. So definition of function. X equals to np.linspace a comma b comma 100. That is, we divide the x range -5 to 5 into 100 small intervals. Then we define the unit function u as lambda x. This will be equals to 1 if x greater than 0, else 0. Now we vectorize this function np dot vectorize u. Now we shall calculate the convolution integration. So calculation of convolution integration. For this purpose, we consider an empty list convolve. Now we shall integrate 0 to x. This range of the x, for each values of the x, we have to subdivide each values of the x 0 to x into a small number of intervals, into a large number of intervals. So for this purpose we write for xx in x, xp x prime, this is x prime, np linspace, this is the integration variable, xx 100, say 100 subdivision. Then we write the product of the two function, that is u xp into u xx minus x prime. Then we calculate the integration using Sims function. Now the Sims function's integration value I will be Sims, this is the y values for each values of the xp. So it will be h comma xp. Now we stored this integrated value to the convol function. So this will be append convol dot append I. So we have done. Now we shall calculate the exact result, because the exact result for this convolution is known to us. So exact results, it will be, say, exact will be lambda x if x greater than 0, else 0. This is the exact result definition. So we vectorize it again. Exact is equals to np dot vectorize, because otherwise we cannot implement numpy operation to the exact function. This is the exact. Now we shall plot the result. Plotting. For plotting function, we write plt dot plot x comma convolve, and say label equals to convolve. Now we plot the exact result, plt dot plot exact result for x, but we don't want to plot the exact result for each values of the x. We want to plot the exact result for, say, 5 after 5 points difference. Exact x 5. Say we label it as circle and label it as exact. Exact. Plt dot. Now we draw the x axis vertical line on and horizontal line. So axis v line, this is for the y axis, is 0, say c equals to gray color, and line style is like this, line width is equals to 1. Similarly for axis h line, that is the x axis, similarly same color gray, line style is, and line width is equals to 1. So now since we have used label, so we need to use the plt dot legend. The location is based, and property size size 10, font size. Now plt dot show. So we have done. Now we want to run the function and run the program. So this will be python unit.py. Since it is interpreter program, suppose there is a there is an error. There should be a bracket. There's an error. There is height. Oh, but it would be there. Here, I think it is right. Yes, this is the result of the convolution of the two unit function. Now the blue curve is the calculated result, and dotted graph is for this dot graph is for the exact result. So it is clear that the exact result, the calculated result coincides with the exact result. Next, we shall calculate the convolution of two Gaussian function. For two Gaussian function, this. Now we know that the Gaussian function is defined like this: 1 by root over 2 pi sigma e to the minus x minus mu by 2 sigma square, it a whole square. Here sigma and mu are the two parameters for the Gaussian function. Sigma is the standard deviation and mu is the mean Gaussian function. Now we shall show that the convolution of the two Gaussian function is a Gaussian function. So now we shall write the program for the convolution of the Gaussian function. Again we open a file, is vim gaussian.py. So similarly the convolution of two Gaussian function. Again we import numpy as np, import matplotlib.pyplot as plt for plotting, and from scipy dot integrate import sims for integration. Now first we define the two parameters for the Gaussian function, that is sigma and mu. Parameters for two Gaussian functions. So P1 is for the first Gaussian function, which is, say, the standard deviation is 0.35 and mean is at 0.8, and P2 is the parameter for the second Gaussian function, 0.7 minus 0.2 is the mean. So the mean and the standard deviation are different. This is for first Gaussian function and this is for second Gaussian function. Now we define range of x, a comma b is equals to minus 5 comma 5. Now we shall define Gaussian function. Say Gaussian function definition GXP. This is the function of x and the parameter p, which is basically mu and sigma. So the sigma is equals to p0, and p is a list, and mu is equals to p1, the first element. So the first element is for sigma and the second element of the list is for mu. Now write the function. So return 1 by sigma into sqrt square root np dot square root 2 into np dot pi. So 1 by root over 2 pi sigma, this is. Now np dot exp minus 1 into 1 point into x minus mu whole square divided by 2 sigma square. Sigma square. Complete. So this is the definition of the Gaussian function. Now we shall calculate the convolution. So calculation of convolution. Like previous examples, so we subdivide the range AB, A comma B into 100 subintervals. So linspace, using the linspace function, A comma B comma 100. Take an empty list. Now for x in xx in x, xp is equals to np dot linspace 0 comma x comma 100, similar to the previous example. So h is equals to g, here xp comma p1. This is for first Gaussian function, and for second Gaussian function xx minus xp comma p2. Right. Now we stored this, the integration I is equals to sims, I equals to sims, this is the y values, this is y and xp. Now we stored this in the convolve list. So convolve append I. So we have calculated the integration of the convolution of two function. Now that is a plot the function. Plotting. Plt dot plot x convolve label is equals to volt. Now we want to plot the two Gaussian function along with the convolved Gaussian function. So for the first Gaussian function, we write better to divide the range from A to B into 1000 sections. So that's why xr is equals to np dot len space a comma b comma 1000 sections for the drawing of the smooth curve of two Gaussian function. Now we plot the first Gaussian function is plt dot plot xr comma g xr comma p1. This is for the first Gaussian function and we label it by Gaussian 1. Function 1. Now we draw the second Gaussian function. Plot xr g xr comma p2. p2 is for p2 parameter is for second Gaussian function. Similarly, we label it as Gaussian function 2. Now we draw the two axes, plt dot ax v line color equals to gray, line style and line width. Similarly, plt dot ax h line gray, ls line width. Now plt dot legend. This is for labeling. Location is based and property. Size 10. And to show the graph, we write use the command plt dot show. Now save it. Now run the Python Gaussian. Oh, there is an error. Minus stop. Oh, for x6 that should be x6. Oh, yes. There should be a bracket. I missed it. Bracket. Now we run the function. Oh, again there is a error. There is a last bracket. We check the function. 1 by sigma root over 2 pi. It's okay. Then multiply e to the power minus x minus mu whole square divided by this. There should be a bracket, I think, minus. There minus and minus is a minus 1 x minus mu whole square Okay. So, okay, right. And now from the graph it is clear that the green one is the first Gaussian function and red one is the second Gaussian function and blue one is the convolved function. So from the graph it is clear that the convolved function is the Gaussian function. So we can say that the convolution of the two Gaussian function is a Gaussian function. Next we go to another example. This one, the convolution of two functions. Suppose fx is e to the power minus x and gx is sin x. Now we know that the exact result of these two convolution to this function is f star gx is e to the minus x plus sin x minus cosine x by 2. You can easily calculate the convolution of these two functions using this integration by parts. It can easily be calculated. Now we shall write the Python code for the convolution of these two functions, and we also compared the convolve function with the exact result. Now we write again, open a file which is vim x exponential and sin pi, ex sin pi. Convolution of exponential is xp minus x and sin x. Again we import numpy as np, import matplotlib.py plot as plt for plotting graph, and for integration we import from scipy dot integrate import sims. Again we take the range of x, a comma b equals to say -5 to 5. For this function we take the range as 0.1 20. Now we define the function. Definition of functions. Here the two functions are there. So f function is equals to lambda x, which is basically exponential function. So numpy dot exp minus x. Actually we import all these quantities in the namespace, all these modules in the namespace. Now the second function is g, lambda x equals to np not sin x. Now is a calculation of convolution. Say x equals to np dot linspace a comma b comma 100. Convolve empty list. Now for xx in x, that is for each values of the x, these x values, each values of the x is the upper limit of the integration 0 to x. So for each range 0 to x, we subdivide the range into say 100 intervals. Linspace 0, x x 100. This is for the intuition. Again we define h, which is the product of these two functions. One is fx fxp and other is g x x minus xp. Then calculate the integration using Sims function hxp, and we append this result to the empty list convol. Now we calculate the exact result, because exact result is known to us, which is equal to 0.5 into np.exp minus x plus np.sin x. This x means this x list array, the array, so the exact will be an array minus cosine x, cosine x, the exact result. Now we shall plot. plt.plot x, convol. Label convol. Next we plot the exact result, x comma exact, that should be O, circle, label is equals to exact result. Again build a plot, sorry, build a xv line 0, gray, line style, line width, similarly for horizontal line, x-axis, line style, line width, legend, this is for legend, based, and this is for show plot, to show the plotting function. So python xn.py. Oh, there is an again error. So there should be a bracket. Yes. So this is the result of the convolution of the two function e to the minus x and sin x. The solid line solid blue color is for the calculated result, and the solid circle, green circle, are for the exact result. So it is clear that the these two result, that is the calculated result, coincides with the exact result. Thank you so much.